we're starting a new chapter, Chapter 4, Applications of Trigonometric Functions. Section 4.1 is applications involving right triangles, so this is going to seem a lot like something we already did in Chapter 2, and in fact it's very similar. So Objective 1 is going to be to solve right triangles. So everything in this section applies to right triangles only, and then you'll see in sections 4.2, 3, and 4, we're letting the triangles not necessarily be right triangles. So make sure you're clear on the difference. So the second objective is going to be to solve applied problems. So here's another chance to work on those word problems where trig is so useful. So the first objective is going to be to solve right triangles. And what does it mean to solve a triangle? Solving a triangle means find all of the missing side lengths and angle measures. So every triangle has 3 side lengths and 3 angle measures, and you're going to need to find any that are missing from the problem statement. So you're going to round side lengths to 2 decimal places and angle measures to 1 decimal place. And we're going to be in degree mode in this whole chapter because we're back to talking about triangles and practical problems where people usually speak in degrees. So recall for a right triangle that the Pythagorean theorem holds only for a right triangle. So make sure you're very clear on when you can and can't use the Pythagorean theorem. So the Pythagorean theorem says if you have a right triangle, then one short side squared plus the other short side squared will equal the long side or the hypotenuse squared. And notice in a right triangle, because we know this one angle is the right angle, the 90-degree angle, then the other 2 angles must add up to 90 degrees. So here's some exercises, and we're going to use the right triangle shown below, and then using the given information, solve the triangle. So I'm going to ask you to write A equals B equals C equals capital A equals capital B equals capital C equals for each of these problems. And make sure you can tell the difference between your capital C and your lowercase c. You might make them look a little different somehow or exaggerate small and large to make sure you're very clear on which one is the side length and which one is the angle measure. So for this triangle, we see that we have a right angle. So angle C is going to be the 90-degree angle. And then we're given that angle B is an angle that is 10 degrees. So we can see that because we know all the 3 angles have to add up to 180 degrees, that angle A must be 80 degrees. And clearly this triangle is not drawn to scale. It's just a generic triangle that can be used for every problem, and it's not going to look right. So don't count on it to look how your problem is. So then we know that side length B is equal to 4. Any of the other side lengths you calculate are going to be approximately equal. So I want you to put approximately equal when that's what's the case. So when we find side lengths A and C, they're going to be approximate because we're going to be using our calculator. So there's lots of different ways to do this. Go back to chapter 2 and remind yourself that you could use any trig function that you have enough information for. I tend to use whichever one seems simplest to me. So I would say, well, I know side length B, and I know angle capital B, and I know then that the tangent of angle capital B will be little b over A. So tangent of B is opposite over adjacent, B over A. So then I can plug in the numbers that I have, and what I'm trying to find is A. So I have that A tangent B equals little b, so A equals B over tan B. So that's going to be 4 over the tangent of 10 degrees. And make sure you have your calculator in degree mode when you're doing these problems. So keep checking that. So you're going to find the tangent of 10 degrees. And then you're going to divide 4 by that. And you're going to get about 22 point, let's see, we round side lengths to 2 decimal places. So side length A is about 22.69. Then you're free to figure out how to solve for side length C however you like. You could use the Pythagorean theorem. If you do, you need to use the whole number that you found in your calculator. So you might want to store this in a register called A. So in my calculator, I can do that. I can name it A so that it's easy to find it. So then you need to use that whole number if you're going to do the Pythagorean theorem and say that a squared plus b squared equals c squared. So you need to do a squared that's in your calculator plus b squared, which is 4, equals c squared. So I'm squaring the number that's in my calculator. And then I'm adding 16. And I'm getting that c squared is approximately 530.615. So c is going to be approximately the square root of that, or 23.04. So c is about 23.04. Let's go back and double check. Round side lengths to 2 decimal places. So that's your solution, and I really want it in this box like this with side length A, B, C, and angle measure capital A, capital B, capital C. So I'll let you do number 20, and we're going to go on to objective 2, where we're going to solve applied problems. So trigonometry is used extensively in lots of different fields. A lot in engineering, but also in navigation and surveying. So in both of these fields, the direction or bearing from a point O, so here's your point O, to a point P equals the acute angle, so that's the smaller one, the acute angle theta, between the ray OP, so here's ray OP1, and the vertical line through O, the north-south line. So for this P1, the bearing from point O to point P1 is denoted north 30 degrees east. So the 30 degrees, the size of the acute angle, goes in the middle. The vertical line that's the closest is the one going north, and then you are east of that vertical line. So let's look at number P2. Now you have a line from O through P2, so that array, sorry, so that's your ray OP2. So the bearing from O to P2, the acute angle, so the smaller one, if you went this way, that would not be an acute angle. So we don't go that way. We go the shorter way. So 50 degrees is the angle. Then the vertical line is going in the south direction. And then you are west of that. So if you don't know these already, north, east, south, west. And people have lots of different little remembering devices if that's not something that's familiar to you. So we read that as 50 degrees west of south. That's the direction you're heading, or the direction you're looking, depending on what you're doing. So then let's look at P3. Again, we want an acute angle. If we go to the south ray, we'll be going more than 90 degrees. So that's the wrong direction. We need to go to the north. So we know the first part's going to be north. The acute angle is 70 degrees, and then we are west of north. So bearing is always given with north or south first, followed by an acute angle, followed by east or west. So let's do the last one together in class just so I can check and make sure that it's coming for you. So it's slightly different when you're doing air navigation. The term azimuth is the positive angle measured clockwise starting from due north. So if you're going this way, an airplane is going to measure your angle this way from due north. So it's a little different for air navigation. So I have an example here that's a surveying example, but I want to do that together in class so that we can draw pictures together, and then I will fill this in and make another movie that has the solution in case you don't capture the whole thing in class. But that's all I'm going to include on this movie now today.